So I just want to start off by talking a little bit about who I am. So I'm a first year medical student. I'm at Mayo Clinic. I'm in Rochester, Minnesota. I got my bachelor's degree in psychology and from William and Mary, and that's in Williamsburg, Virginia. And just I guess to sort of like to show that I guess you're like who is teaching me. I did get 521 on my MCAT. Um, so yeah. And then my goals are to one, obviously help you prepare for the MCAT. And then two, like I think what makes the MCAT a little bit difficult is that, at least from a mental perspective, is that some people feel like that why am I learning all of this? This isn't relevant to medicine at all. And a lot of those passages and the questions, I'm going to be real with you, really aren't. But what I wanted to do is to curate some passages and some questions that were really geared towards medicine. And so I think it's more interesting. It's directly related to your goal of becoming a physician. And I think that's sort of the best use of our time here. And then hopefully you guys have fun. So if you guys can go to like the first passage, it's like the first physics passage. We're gonna start there. This is you can admire my creative naming scheme here. So it's like the rhythm of the pump unveiling the heart's hydraulic symphony. And then on the Google Doc, this is just the first physics passage. So I think what I'm going to do is I'm going to give everybody time to read it. How about, let's say, 5 minutes, and then we'll start going through the questions and walking through them, if that sounds all right with everybody. Cool. So I'll start a timer for it shouldn't take you that long to read it, but how about we give everybody until like 5:08 to read the passage, and I'll also click through the figures, and then we'll start looking at the questions.
I have a quick question. Am I supposed to be accessing these slides somewhere or just reading it off your PowerPoint?
Yeah, so if you look in the chat, I should have the Google Doc in there if you want to pull it up too. So then you don't have to worry about losing it. Can you see it in the chat?
Maybe I came in a little late, but my chat only has two things in it and there's no link.
Ooh, okay. Gotcha. Let me see if I can pull it up for you. Okay, can you see it now?
Yep, I got it. Thank
Okay.
you.
Yeah. All right, and then when you guys are done reading, if you guys can like type or put thumbs up, smiley face, whatever. And then once I start getting a decent amount of people saying that they're done reading, then we'll move on to the question. Alrighty, guys. So I'm getting a decent number of thumbs up. If you're not done reading, that's perfectly fine. But I just want to make sure that we have time to go over most of the questions. So the first question, which of these following reasons best describes why the volume remains constant despite pressure increase section during section BC on the curve? So that's referring to the pressure volume loop. So let me go back here so you guys can see that. So and it was in the passage. So let's go over like what the pressure volume loop is trying to tell you. So at point A, that's the point at which the mitral valve opens, and that's when blood's going to be filling into the heart during diastole. And then from B to C, the mitral valve is going to close, and then the ventricles it's called isovolumetric contraction, and then the aorta is going to open, blood's going to pump from the ventricles out into the aorta, and then back through the cycle. So that's sort of the cycle of the heart. So let's go through each of the answer choices and talk about which ones we can immediately eliminate and why. So the ideal gas law, you can eliminate right off the bat because we're talking about liquids. Blood is a liquid. An ideal gas law is going to be dealing with gases. So A is out. During efflux, so during section BC, while on that graph, blood is staying in the ventricles. It's not being effluxed. So D's out. Boyle's law is P1V1 equals P2V2 when N, R, and T are constant in your ideal gas law. It's sort of the same reasoning as A. You can eliminate it because it's really going to be talking about gases. But the other way you could do it is if you really wanted to do the math, like pressure is increasing and volume is going to have to decrease. But during section BC, we're told that the volume remains constant, so that math doesn't work out. So liquid incompressibility is like the default answer choice here. And then you can also just remember that liquids are incompressible. That's like one of the fundamental properties of liquids. Does that make sense to everybody, or hopefully that made sense? Makes sense. Okay, cool. So now on to question 2. So during the pressurization phase BC, what is the pressure in a narrow valve entrance compared to the wider chamber? So I think this is a little bit of a tougher question. So let's go through each of the answer choices like the same. So 0 is out. So during the pressure phase BC, there's going to be a pressure differential during that phase. It can't be the same, sort of by the same reasoning, because there is a pressure differential. Now, so now you're between smaller and larger. So smaller is going to be the correct answer because the Venturi effect states that as fluid flows through a constricted section, there is a reduction in fluid pressure. So this is a question really about the Venturi effect and why that's the case. Larger is kind of like a trapped answer choice, and you might be thinking like, since pressure is increasing, volume is also going up, but volume's not. So that's why the pressure is smaller, because of the Venturi effect. So now we'll go on to question 3. So during which segment of the cycle does the mechanical potential energy of the heart increase? So if you look back on your pressure volume route, so let's go through CD. So CD is when blood is being ejected from the ventricles into the aorta. It's a huge, like the pressure differential in the ventricles has finally exceeded that of the aorta above it, and it's going out. So work is actively being done during phase CD because blood is being effluxed out of the ventricles into the aorta. During phase AB, it's the opposite. The atria, blood is flowing from the atria into the ventricles. So work is also being done during phase AB. So option choice A is out and option choice D is out. So now you're left with option B and option C. So let's talk about why option B is the correct answer here. So as the pressure is going up in phase BC during isovolumetric contraction, you have potential energy being built up for them work to be done, like I just said, during phase CD. C is incorrect because when that D to A is actually what's called isovolumetric relaxation, and your mechanical energy, your potential energy is decreasing as blood is eventually going to flow back into the atria. So it's not increasing because work isn't about to be done. It's the pressure is actually decreasing, so your mechanical energy is also decreasing. Cool. Now
I have a
let's
question.
Yeah.
So a couple things. One, for strategy purposes, do you approach these questions by always looking at the answer choice and seeing what you automatically can eliminate before diving into trying to solve it?
Yeah, I would say that's an excellent test taking strategy in general, and especially for the MCAT. Because for the MCAT, as you can see, that was a pretty dense passage, and you have all these terms that you're trying to think about. So I think one of the things I would encourage you guys to think about, especially in the hard sciences passages, is to automatically look at your answer choice and be like, what is wrong? Like, what can I automatically? Because that takes out, if you eliminate one answer choice, now you only have 3 answers. You've increased your odds by 25%. You rule out 2 answer choices. Now you have a 50-50 shot. So while you might end up choosing like the wrong one between 2 tough answer choices, at least you've given yourself a better fighting chance, if that makes sense.
Yeah, absolutely. And then my next question was kind of, you briefly mentioned it, that this was a dense paragraph or passage, and a lot of them tend to be. Do you have a strategy for, like, do you outline as you read? Obviously, you're not going to remember the details in its entirety of the passage. And then if the question requires you to go back, then you do. But do you have a strategy for like outlining as you go, or no?
Yeah, good question. So I think my general approach to let me see. Sorry. I think my general approach has always been that to read the passage at least once and make sure you get through it so you know where everything is in the passage, and then use the questions to guide you to the material that you're going to need and to actually look at in further depth. So I would at least go through the passage at least once, read it, know where everything is, like know where your tables are, know where your figures are. So then when you get to a question, you're not going to be like, oh, let me have to go find that all over again. Does that answer your question?
Yeah, absolutely. And then the last one was in regards to that one we just did, would it be an okay approach to like look at the arrows and see, hey, there's work being put into the system. You're going to gain potential energy if you're putting work into the system. Whereas D to A, you're losing energy because the arrows are pointing away.
Um, I think you have to be a little careful with that. I think you really kind of have to surmise it from your knowledge of pressure volume loops and then what it tells you in the passage, because I think in the passage it even tells you or you can infer from the passage like when work is being done and when nothing's happening. So I would go by that instead of trying to necessarily look at the arrows, if that makes sense.
Yeah, absolutely. Thank you.
Yeah.
I have a follow-up question about like keeping track of where everything is. Do you tend to highlight as you read just to have an idea of where things are, or do you just mentally keep track of it?
Sorry, could you repeat that? I
Yeah,
couldn't really.
sorry. When you're trying to figure out and keep track of where things are in the passages that you're reading, are you highlighting as you go, or are you just mentally keeping track?
Oh, yeah, good question. So during my MCAT and when I was actually taking it, about a year and a half ago, I didn't really have time to mess with the highlighting stuff. So I usually would just be like, okay, figure 1 is the diagram about what's happening to the heart. And then like figure 2 is my PV loop. But highlighting isn't a bad idea if like, so you can easily find stuff again if that works better for you.
Thank you.
Yeah. Let me find my cursor. Okay. So let's go on to the very last question. So which of the following quantities is given by the area enclosed by the loop? So again, using that same approach that I've been going through for this passage, is that let's talk about the answer choices that we can automatically rule out, because that's going to help us a lot. So the total number of moles of blood in the heart times temperature, you can rule that out. There's nothing about moles that you can derive from a PV loop, at least not this type of PV loop. The tissue displacement during one cardiac cycle is also out. Doesn't tell you anything about tissue or what's being displaced or how much is being displaced. So A and B are automatically just gone. Now C, I think people can get confused by this, but there's not really a great way to calculate the net force that's being exerted during one cardiac cycle, because this is just a description of what's happening continuously in the heart. It's not telling you about it's not talking really about force. Now it is telling you about work. Now there's a couple of ways, so D is the correct answer here. Now you can work this out mathematically. So the area within a loop has units of pressure times volume. So basically, if you work that out, so pressure is force over, distance squared, then volume is, and then, volume is cubed, so, or distance cubed. So then force over distance equals work. Alternatively, you can just memorize that the area within a closed loop on a PV diagram always gives you the work performed by a heat engine. And in this scenario, the heart is the heat engine. So 2 ways. You can either do the math if your brain works that way, or you can just remember that if I see a PV loop, the area is always going to be work done. Makes sense? Cool. All right. So I'm going to give you guys a choice. Do we want to go on and do another physics passage, or do you guys want to go and do one of the chemistry ones? Because I have a lot and I want to be respectful of you guys' time. So if you guys want to stay here and we get through all the content, that'd be awesome. I know they scheduled it for 45 minutes, but I'm more than willing to go through all this content. So we can just go through it in chronological order like I have it on the Google Doc.
Just have a quick question then.
Mhm.
If if the group collectively decides that they want to do all of the content, and we may not be able to make the entirety of this, is it recorded for us to view later?
Yeah, this is being recorded.
Awesome, thank you.
Yeah. All right, so let's go through in chronological order, and then if we get crunched for time, we can always start picking up the pace a little bit. All right, so on to the next passage. This one, this isn't a super dense passage. So hopefully a little bit easier and a little bit more conceptually not as challenging. So how about if I give you guys until about 5:28 to read the passage on the Google Doc and the table. Actually, not even you have 3 minutes. Read the passage, and then we'll start going through the questions.
was gonna ask or propose, can we answer the questions as well?
Oh, do you want to do it where like I ask you guys to give me your answer or something?
That's a little bit more engaging for me at least.
Yeah, sure. That's totally fine. Yeah, thank you. All right, so then once you guys are done reading the passage, and on the real MCAT, you don't have a calculator, but I'm more than happy as you guys are learning and starting out if you need to get a calculator and actually do some of these things. And obviously, pen and paper is super useful. So then for question 1, read the question, do your calculation. It's not a super complex calculation, and then we'll talk about it. And we'll go over like my same approach of which ones can you eliminate sort of off the bat, and which ones should you take more seriously. All right, go on and put your answers in the chat, and then let's talk about it. I'll give people about 30 more seconds, and then we'll talk about it. All right, guys, so let's talk about this question. So this one is, how long after being touched on his or her foot would it take the nerve impulse to travel the entire length of the sciatic nerve of person C? So this one is just a simple speed, distance calculation using like speed equals distance over time. So if speed equals distance over time, then you can plug that in. So since the distance is 1 meter and you're traveling 50 meters a second, you just do some cross multiplication and it should work out to 0.02 seconds. So option C, because 1/50 is 2/100, or 1/50. So 0.02 seconds for that question. Question 2 is likewise, pretty simple math question. So I'll give you guys about a minute to get your calculator and do that calculation, and then we'll talk about it. Then you can put it in the chat once you've answered it. All right. So let's talk about this question. So the answer to this one is D. So this one you can do a little bit of math, but you can also, using the table, you can also eliminate some answer choices right off the bat. So you can eliminate option B because both people have a sciatic nerve length of 0.8 meters, but option D is traveling slower. So obviously, like, B's out because he can't be the slowest. Then A, it's longer and he's only going marginally faster, so you can probably get rid of A. And then C just is a no-brainer because 50 meters a second is so much faster. So you can work through it that way, or you could go on and do the math, and you can do 0.8 times 1/20, and that gives you 0.004 seconds, 0.04 seconds. And that's the longest out of all of them. All right. Question 3, I'll give you a minute to do the calculation and then we'll move on. All right, go on and put your answers in the chat. Good. So, yep, excellent. So this one is A. So person D takes 0.04 seconds. Person B takes 0.02 seconds. So the difference between the two is 0.02 seconds. So that's option A. All right, question 4. This one's also pretty straightforward distance calculation. So I'll give you like 45 seconds to crunch some numbers in your calculator. And then put your answers in the chat. Alrighty, good. So this one is A. So if you do 90 meters times, and you have to flip it. So 1 second over 30 meters, that gives you 3 seconds. Because that's the speed at which they're traveling, and you just do cross multiplication, cancel out the units, and you get 3 seconds. All right, last question. So person E is tested and they have a static nerve length of 120 meters per second. And then do some math, put it in the chat, and then we'll talk about it. All right, cool. So this one is A. So if you convert 0.005, you can do that as 5/1000, and then you multiply that by 120. That roughly gets you 600/1000, and then simplifying that down gives you 0.6 or 6 out of 10, so 0.6 meters. So this section is applying it, to neuroscience, obviously, and making sure that know your equations, know how you derive like speed, distance, and time, and know the interplay of those relationships. So now we're going to go to chemistry. I'm sorry for my physics nerds out there, but unfortunately chemistry is on the MCAT. So my first passage, so aptly named, is Radiant Remedies, Unleashing the Power of Therapeutic Radioisotopes. Beautiful name for a passage there. So why don't we take about, this is another dense passage, guys, and this time it's chemistry. So on the Google Docs, it's only about a page. Take about, take about 4 minutes to read the passage. Go on and read the first question, and then put it in the chat. And then once a couple of people have put their answer in the chat, we'll talk about it. Alrighty, go on to make your best guess for question 1. I know it was a dense passage and it was a lot to entertain. So part of it is, if you try and get through as much as you can and then make your best educated guess given the time constraints that you have. And on the MCAT, you'd have a little bit longer, but it's about 9 minutes per passage, which is actually not a lot of time. All right, cool. So let's talk about this one. Honestly, the hardest part of this is like taking in all the information, and then you get done reading that dense passage, and then yeah, more graphs to look at. So let's sort of like kind of go through a general approach. So half-life is the amount of time that it takes for a substance for 50% of that thing to be gone, right? So half-life. So for copper 64, it's 12.8 hours. For iodine 31, it's 193 hours. And then for yttrium 90 or tritium 90, it's 64. So part of this is finding a curve in which you can kind of ballpark what looks about right. So which one has the quickest half-life? And that's going to be copper 64. So the one that decays the fastest has to have that line that is going to go down the furthest pretty quickly. So option D is out because the one that decays the quickest is tritium 90. And then also A is out because the quickest is tritium 90. So then the one that's kind of hard is picking between B and C. And B is the correct answer here. So iodine 31 is going to have the longest one. So that's why it has to be the one at the very top. It has to be that first line. It's going to have the longest half-life. It's going to take a really long time for iodine 131 to decay. And then yttrium 90 is going to be right there in the middle. And then you have copper 64. I hope that makes sense as like how to approach looking at those graphs and why you can eliminate, take out A and D, and then focus your attention on the options B and C. All right. So we're going to go to question 2. This is a little bit more conceptual. So from the table provided in the passage, which radioisotope is best used to target and destroy large homogeneous tumors? So I'll give you guys about a minute to think about it and then put your answers in the chat. And I know we're running up right on that 5:45 initial deadline, and I do have more to go through. So if you're willing to stay, perfect. I will stay here, and as long as I have a couple of people, I'll keep going, and the whole thing will be recorded. If you need to leave, no hard feelings. All right, so let's talk about this one. This one looks like a little bit of a tougher question. So for this question, you're looking at, you want to pick the substance that's a beta emitter, because we're told that beta particles are more powerful. And while they do have a small range of action, they're more powerful, and you want one that has a large Emax. So the compound that's a beta emitter with the largest Emax is going to be yttrium 90. That makes sense. For question 3, so radioactive iodine 131 is given to patients for the treatment of hyperthyroidism caused by Graves' disease. This is an autoimmune condition. So which of the following equations correctly describes the radioactive decay of iodine 131? Oh, yeah, you have a question? Go ahead.
My apologies. I think I lost connection, but what was the answer for number 2?
The answer for number 2 was Tytrium 90, because it was a beta emitter with the largest Emax.
You said yttrium 90,
Yeah,
and that was determined based off the Emax.
yeah, we wanted a beta emitter, and then we wanted the beta emitter with the largest Emax.
Okay, thank you.
Mhm. And you can also use that because it says alpha particles are in the passage, tells you they're used to deliver radiation in a highly localized manner. And in a large tumor, you're going to want something that has a larger range of action than just purely localized.
Can you explain for the previous question why we wouldn't want to use a alpha emitter instead of a beta?
Yeah, so great question. So the reason why, if you go back to the passage, is that so it says that beta emitters release highly energetic electrons that can penetrate several millimeters of tissue. So for a large tumor, there's definitely going to be several millimeters of tissue. Then alpha emitters are primarily used for highly localized lesions. So that's the reason why you want a beta emitter. And then why specifically yttrium 90 is because it has the highest Emax of the beta emitters. Does that make sense?
Yeah, perfect sense. Thank you.
Yeah. So if you guys want to quickly put in your answer for question 3, and then we'll talk about it. All right, so let's talk about question 3. So let's talk about answer choices where even, let's say you forgot about, your radionuclide decay equations, and you're like, oh my God, I can't believe I didn't study this for my MCAT. I'm like screwed. So let's talk about it. So what are some answer choices that we can automatically sort of like get rid of if we have a little bit of baseline knowledge? So we can get rid of B. You're never going to have 2 elements in a radioactive decay equation on the same side. Okay, so B is out. D is out because you're always going to give off beta particles. So it's not going to be on the left side of the equation. It's going to be on the right side. So your beta particle is always going to be on your right side. So now using those 2 principles that you're not going to have in radioactive decay, you're not going to have 2 elements on the same side of an equation, and your beta particle is always going to be on your right side. You can get rid of B and D. So now you're left between A and C. A's out, right? Because it's talking about the decay of iodine, not of xenon. So even if you didn't know how to write the specific equation, if you knew A was probably actually the easiest one to eliminate because iodine's on the wrong side of the equation. Your beta particle has to be on the right, and then your two elements, at least with radioactive decay, are not going to be on the same side. Okay, so C is your correct answer. Alrighty. Let's go on to question 4. I'll give you guys about, let's do about 45 seconds. then put your answer in the chat. Oh, and definitely pull up a periodic table if you haven't already. Super, you're gonna need it for this question actually if you've memorized it. Good for you. You were better than me when I took my MCAT. I don't think you need it for any other question though, but for this one you do. Okay, cool. So let's talk about this one. So if you got the previous question correct, you can actually use that here to help you. So you know that the beta particle, you're going to get a new element, right? So the question is, which one are you going to get? You're not going to get silicon 31. The number isn't going to go down. So B and C are out. So you're going to stay at 32. The element is going to change. Right? Because so since the element changes, it's going to be sulfur. And you can write out the equation for that. So the correct answer is A. So sulfur 32. So again, I would eliminate B and C. And then it's about moving the right direction on the periodic table for choosing between sulfur and silicon. So you're going to stay at 32, B and C are out, and then move the right way on the periodic table. All right, last question. So this is a little bit about building on what you've read in the passage. How about we take like 30 seconds and then put our answers in the chat. Yeah, good guys. This is C. Does anybody, so I'll explain it for this one. So they're both not going to stop at paper and they're both not going to stop at aluminum. So A and D are out because they're different. We're told in the passage that they have fundamentally different properties when it comes to their strength. Beta particles are stronger. So you can eliminate option B. A is not going to go through paper all the way to aluminum because it's weaker than a beta particle. So by process of elimination, it has to be C. All right. So this is our last passage for today, and then the rest are going to be super quick, discrete questions. So I promise I'm not going to keep you like for a whole nother hour. So if you want to stay, this is our last passage. Then the rest are going to be discrete questions, which are going to be a lot faster than these because I've been taking my time because I want to give people the time to read the passages. So this is our last passage. This is about an antidepressant, citalopram, also known as Celexa. A lot of you guys might have heard of antidepressants. So this is relevant to medicine. Depression is one of the most commonly treated conditions. So let's take about This is super dense. So I'm going to give you time, read the passage, get through the first question, put in your answer choice, and then let's talk about it. This is actually one of the higher yield passages. This is good to be able to get through an organic chemistry passage. Also, I'll give you guys a test taking strategy. Sometimes I would recommend reading the passage at least once, but sometimes you can read the questions. I'll give you a hint here. For the first 3 questions, you don't even need anything in the passage. It's literally just based off your prior chemistry knowledge. So sometimes that can save you some time. All right, guys, let's start putting in your answer choices for question 1. Since the first 3 questions, you don't really need the passage and it's more of like sort of like pseudo discrete questions. And let's talk about it. All right, cool. So I won't be spoiling anything by going over question 1 for the passage. So let's talk about this. So this is just a simple or testing your knowledge of organic chemistry. So you have a triple bond, right? By definition, when you have 2 atoms that are in a triple bond, it's going to be linear. When something's linear, it's 180 degrees. So option D is correct. So great job to everybody who chose option D. To review the other ones, sp2 does have a 120-degree bond angle, but that's not what it's asking you. So it's correct information, but it's the wrong answer choice. And then the other 2 are mismatched. All right, I'll give you guys about a minute to do question 2. Also doesn't really rely on your knowledge in the passage, so you should be able to answer it just based off of knowledge. But information in the passage can't help. Sometimes it reminds you of things. All right, let's go on and put our answer choices in the chat for question 2. Again, this doesn't really rely on knowledge from the passage. All righty, so let's talk about question number 2. All right, so in this situation, we have 2 enantiomers, right? So we have 2 mirror images. That's the only thing that's going to be different between the 2. So most chemical properties of enantiomers are actually going to be pretty similar. So your boiling point is going to be similar. The only thing that's changing is that the way that they rotate plane polarized light is different. So boiling point is going to stay the same. Your IR spectrum, you have this, it's going to remain the same. The same elements are there. They're just in slightly different configurations. For an IR spectrum, enantiomers aren't going to change what the output of that. Now, here's where it gets a little tricky. So we know 1 and 2 are correct, and they're literally correct. So you can eliminate option A since option A doesn't have choice number 2. But that doesn't really help you because B, C, and D all have 1 and 2. So let's see if we can eliminate 1. So let's go with option 3. Rated the reaction with the same achiral agent. Okay, so conceptually, so you have an R and an S. If you react them with something that's achiral, it's not messing with their chirality. It's not going to react with those reactions in a different manner because it itself is not chiral. So there shouldn't be a difference in how an achiral reagent reacts with a chiral agent. So 3 is out. So 3 is an incorrect answer choice. So what about option 4? Rated reaction with the same chiral reagent. Now this will be different because it shares chirality with these 2 agents. So it will react differentially because if you have RR and RS, you're going to get different things. So the correct answer is going to be B. That's correct because 1, 2, and actually no, sorry. Option C is correct. 1, 2, and 3. Those are going to be identical. So B is a little tricky because it flips the 2. So C is correct. 1, 2, and 3. That's what stays the same. 4 is different. So 4 can't be in the correct answer choice. Does that make sense, or did I confuse people? Okay. Yeah, sure. Same thing. Sure thing. So when you have enantiomers, they're going to share most of their same basic chemical properties. So boiling point isn't going to change. IR spectrum isn't going to change because you have the same elements making up those compounds. What is going to change is anything that disrupts or changes their chirality. So if you react chiral agents with another chiral reagent, you're going to get different products most likely. So 3 is correct, and option 3 is correct in that sense, because they're going to, since it's achiral and it's not messing with that chirality, it's going to react with both R citalopram and S citalopram the same. So it's acting like what's identical. So 1, 2, and 3 are correct. Okay, cool. Sorry if I confused you. I hope my second explanation made more sense. All right, question 3. For those of you who have had the displeasure of going through organic chemistry, I used to hate, I used to hate, and you have to count around the things. This is what you have to do for this question. Also doesn't rely on your knowledge gleaned from the passage. So get out a sheet of paper and do the rules for counting a molecule, a central carbon as R and S, and see which one gets you RR. Okay. Then we'll talk about this one because I know this is confusing. It was confusing as heck when I went through school. Then put your answer in the chat, and then since it's probably been a while since you've read the passage, well, you only need table 1 and the log p values and table 2 to answer the second 2 questions. All right, guys. Let's go through this question. All right, can you guys see my little annotation thing that I drew? Like, can you see that when I draw? Yeah, okay. So the correct answer here is C. So shout out if you got that, because this is a little difficult. So let's go through it. So you have to assign priority to the groups around your 2 central carbons, right? So let's start with the rightward one. So your carboxyl group is gonna be or actually your OH is going to be your first number 1 because oxygen takes higher priority. Then it's going to be your carboxyl. Then it's the rest of this side chain here is 3. And then your hydrogen lastly is 4. Same thing for the leftward carbon. OH is number 1. Carboxyl is 2. The side chain, the rest of the compound is 3. And then hydrogen is 4. So remember, R is clockwise, S is counterclockwise. So let's start with the leftward carbon. So this one, you can just, so your lowest priority group is on a dotted line, which is correct. So you can just go around clockwise. So you go 1, 2, 3. So your leftward carbon is R, right? Because your hydrogen is in the correct position. Now let's do the rightward carbon. So oxygen's number 1, right? Then 2, and then 3. So you initially go like, oh, this is S, right? But remember, your hydrogen is on it's drawn on a wedge. So in order, your lowest priority group has to be on a dotted line, is how I remember this. Your lowest priority group in these has to be on a dotted line. So if that's the case, since it's not, you have to flip it. And since you flip those 2 groups, your initial configuration is going to be incorrect. So instead of S, it's going to automatically change to R. So that's RR, tartaric acid. Does that make sense to everybody? So this is just a little bit of a lesson in assigning priority to your chemical surrounding groups on your central carbons and going through that. So yeah, let's go through that again, because this is really important, not only for organic chemistry, but for your MCAT too. So again, let's start with our rightward carbon. So you can look up like priority rules and assigning chirality. So I'd encourage you to look that up, but I'll tell you what they are here. So oxygen of the groups around this rightward carbon is going to have the most priority. So that's number 1. Then your carboxyl group, your carboxylic acid. That's going to be 2. The rest of the molecule is going to be 3. And then hydrogen's 4. Now there's an arbitrary rule here that your lowest priority group has to be facing away from you. Okay, it's just arbitrary why that is. So whenever I see that that's the case, I'm making a note that the configuration that I initially did when I go 1, 2, 3, and I'm going counterclockwise, which would tell me that it's S, it's going to flip to R, because since I flipped 2 groups, I'm also going to flip my configuration. So how I initially assigned this central carbon right here as S is actually R. So now for the more straightforward one. Oxygen again is 1, your carboxylic acid is 2, and then the rest of your molecule is 3. This time, you can stick with your first assigned priority. Since it's 1, 2, 3, because hydrogen is facing away from you, it's not on the wedge bond, it's going into the page, it's not coming out at you. So when you go 1, 2, 3, you're like, oh, this is an R carbon, you get to keep it as R. So this is RR tartaric acid. That help, Jasmine? Okay, cool.
Can we quickly go through what the first and the second option would be?
Oh, I'm sorry, can you repeat that for me?
Can we quickly go through what the first option would be in terms of our
Oh, what
priority?
the first option would be?
Yeah.
Yeah, sure. So let's go through that. So again, so draw. So oxygen is 1, carboxyl is 2, and then the rest of the molecule is 3. This time, this one is correctly placed. So this is S, then 1, 2, 3. This one is still R. So this is RS, tartaric acid.
Thank you.
Yeah. All right, quickly, I need to delete my annotations. Anyway, you can see them. So in table 1, what is the best solvent for scientists to separate the diastereomers? So go look at that table, and it's been a while since we've looked at it. So I'll explain this for the sake of time and clarity, because I know it's been a while since we've looked at that passage and we just got through drawing and you're like, oh my God, this is too much. Totally feel you there. So let's go through this. So in table 1, which is the best solvent for scientists to use to separate the diastereomers? So in table A, or in table 1, A is out because there's no difference in how the two react between room temperature and a hot water bath. Option D can also be ruled out because the solute is visible at room temperature and a hot water bath. So that literally doesn't help you at all if you're a chemist. It's the same thing. So options A and D, now you have a 50-50 shot between B and C. Now here, C is the correct answer. Why? So the solutes don't dissolve at room temperature, but they do dissolve at a higher temperature, so that the compound of interest it precipitates out of solution as the temperature is gradually lowered. Okay. So in that table, what it's telling you is that at room temperature, you have a solute. that's visible, hot water bath, there's no solute visible. So it dissolves. So then the compound of interest is going to precipitate out as you then cool it down. Now in option B, why you're like it just flips to 2. So why is option B wrong? So it's difficult to continue the experiment if the solute dissolves in room temperature, because then the temperature of solution will need to be lowered to below room temperature. That's physically harder to achieve than in the opposite situation like you had in C. So the solvent and solute mixture is usually heated to a high temperature and then allowed to cool slowly. So then the crystals of the compound of interest can precipitate out a solution above room temperature. So that's the reason why, because what option B would get you is that in order to have a precipitate, you'd have to get it below room temperature, which can be like harder to do. Whereas if you heat something up, it's probably gonna melt out. And you don't have to have any special conditions to do that. All right, this is something that you actually see in medical school, not the log p-values. You can forget about log p-values after you take this test, but volume of distribution and lipophilicity versus lipophobicity stays with you in pharmacology. So how about you take a minute, go look at table 2, and then look at the question, and then put your answer, and then we'll talk about it. Alrighty, go on and make your best guess. It's totally fine if you're wrong. We're here to learn because this isn't anything real near MCAT situations. It's a lot quicker of a pace. Alrighty, so let's talk about this question, guys. All right. So this is asking a little bit about pharmacology. It's a fair question because you can answer it based off of the passage and you don't need to know any physiological principles, but I'll talk about pharmacology a little bit just because it's interesting and you'll see it again in your first year of medical school. All right. So option A, we can rule out because citalopram, based on the log p-value, is lipophilic. It likes fat. It's not lipophobic. Using that same logic, we can rule out option C. Okay, because citalopram, based on its log p-value, is lipophilic. So now you have option B and option D. Option D is wrong. Why? So something that's lipophilic is going to have a high volume of distribution. Why is that? because fat is located widely throughout the body. And where fat goes, so a drug that's lipophilic, the drug is going to go. So because it likes fat and fat is distributed all around the body, it's going to have a high volume of distribution. And what volume of distribution means is that it's all throughout the body. Makes sense? So option B is correct because it's something that's lipophilic. Lipophilic compounds, you can write this down as a key point. Lipophilic compounds are going to be widely distributed in the body. And as a result, they're going to have a high volume of distribution. They're going to be all over the body. Something that has a low volume of distribution would be something like a hydrophilic compound. A hydrophilic compound isn't going to go all throughout the body. It's going to stay in specific reservoirs where you have more favorable circumstances, but fat is everywhere. Makes sense? Cool. So now I promise that was the that was the brunt. If you were here just for the passages, you can leave now because now we're going to do discrete questions. These are going to go by much quicker. I'm not going to give you guys a bunch of time. I'm going to give you maybe like 2 minutes because that's about the time that you have on the MCAT, maybe about 2 minutes per question. And I have 5 questions for physics and 5 questions for chemistry. And it's not going to take crazy super long. All right. And then we'll finish up. And if you guys have any extra questions or you want to talk to me about strategy or when you want to take your MCAT, I'm more than happy to talk about that with you guys. And sorry for going so much over. I hope this is helpful. All right, physics question number 1. A 100 kilogram block of wood is traveling with a constant velocity on ice. What is the normal force? All right, go on and put your answers in the chat and then we'll get going. All right, so the answer to this question is D. So the normal force on an object is basically the force of gravity upon that object, basically, is one way you can think about it. So the normal force is just mass times acceleration and the gravity constant, which is 10 meters per second squared. So since it's 100 kilograms, and then you have 10, you just multiply, so it's 1,000 newtons. So M times A. In this case, it's G since it's gravity, so M times G. So 10 times 10 is 1,000. All right, question to you. A rock has a mass of 100 kilograms. A man pushes the rock on its side with a force of 300 newtons. Moving the rock, if the coefficient of kinetic friction between the rock and the ground is 0.25, what is the net force of the rock? I'll give you a hint for the equation. Go on and start working on it. And as you're working, I'm going to give you a hint. So the net force is going to equal the force of the push minus the force of friction. I'm not going to give you the formulas for that, but that's just a start. So calculate what the force of the push is, and then what's the force of the rock. All right, go on and put your answers in the chat. And remember, you can use a calculator on the real MCAT. You wouldn't have a calculator, but we're learning, and the more important part is that you know how to apply the formulas. Then you can do shortcut math on the real thing. You're going to make your best guess. I know this is quick. This is a little bit of a quicker pace, but the discrete questions you might want to try and spend a little bit less time on the real thing than the passages. So 300, right? So that's the force of the push. So then you have to find what the force of friction is. So let's talk about it. And then if everybody's okay, I can actually, if you guys have the Google Doc pulled up, I'll let you guys use that as a resource, and I'll share my iPad screen so that I can like do the math for you guys, since that'll be a little more helpful. Okay, so my screen share is loading. Okay, can you guys now see my screen? Okay, cool. So let's talk about for this question. So we know that that's a little. So we know that the force of the push that equals 300 newtons. Now your force of friction equals mu. And then, so that's the coefficient of kinetic friction. That's all that is. And then mg. So that's going to equal 0.25 in this case. Then the mass of the object is 100 kilograms. And then G for the MCAT, technically, I'm sure you guys who those of you who have taken physics, 9.8, you can assume it's 10. It's nice, easy math. And you don't have to be trying to calculate decimal points. So then if you calculate that all out, that gives you approximately 250 newtons. So if you subtract let me see, why isn't this working? So if you subtract F push minus F friction, you get approximately 50 newtons. And the reason why it's 55 is because it's really 9.8. So it's going to be a little off. But you got really close by doing what I call MCAT math, by just approximating. So you're going to get around like 50-ish. So everything else is orders of magnitude off. So you can be like 50 isn't an answer choice. That's okay. Go with the one. They're not going to give you numbers on the MCAT. Like, I'll give you a scenario which they wouldn't give you. They wouldn't give you like 51 and 53 newtons as answer choices here. That's unreasonable. They're always going to give you answer choices with a wide spread like this. So, and that's universal. That's never going to change. All right, question 3. Box A has a mass of 100 kilograms. Box B has a mass of 50, and box C has a mass of 25. They're arranged in the following arrangement. I think there's a picture, but just imagine that they're on top of each other, like box A, box B, box C. That's what I mean. So they're literally stacked on top of each other. What's the normal force exerted by the ground experienced by box A? So I'll give you guys a little bit to calculate it, and then we'll get through it. Wait, I can save this. Then, like I said, do MCAT math here, and don't worry about 9.8 or 9.89 or 9.9. Just round it to 10. It'll make your life a lot easier. Let's go on and put your answers in the chat, because I want to be mindful of everybody's time and also get through the questions. I'm going to try and be done by 6:45, literally an hour after it. It's okay. You guys get good MCAT prep. I hope it's useful. All right, answers in the chat for this one, for number 3. All right, just make your best guess. It's okay if you get it wrong. Okay, B. So let's talk about this one. So your normal force, it normally just equals mass times gravity, right? But you have 3 masses, so you can just add all of your masses. So M1 equals 100, M2 equals 50, M3 equals 25. If you add all that up, so M1 through 3, you get 175 kilograms. G equals 10 meters per second squared. So then your force is going to be 175 times 10. So you get 1750 newtons. All right. All right. Question number 4, you can calculate out, but it's a little bit more than it's a little bit of a conceptual question. So go on and read that. If you need to do the mathy math, do that, and then we'll continue forward. All right, go and put your answers in the chat for this one, and then we'll continue going forward. And then I have 5 chemistry questions, and those will hopefully be a little bit more applicable to everybody, because I know some people probably haven't had physics. Make your best guess. All right, so this one is a little bit of a trickier one. So if you calculate it 400 newtons, that's the maximum amount of friction possible. However, static friction is only as large as necessary for the object to stay static and counteract the opposing force until the force due to static friction reaches its maximum amount. So that's like a general principle. So static friction is only as large as you need it for it to stay static. So the correct answer is actually 50 newtons. It's what the child is pushing, because he hasn't overcome that maximum threshold of 400 newtons to begin moving it. So the static friction is only going to be the force that he's exerting on the refrigerator. So the answer is B, 50 newtons. All right, last one. An elevator's motion is through the action of a single cable. The elevator has a gravitational force of 2000 newtons. When the elevator is moving downwards at a constant, I'm going to highlight constant velocity, how much tension is in the cable? So slightly less than 2000, equal to 2000, greater than 2000, or close to 0. This is more conceptual, so you don't need to do the math. You want to put your answer in the chat since this one's a little bit more conceptual. All right, so the answer to this question, and I know we're going a little quick, but the discrete questions in general are going to be a little quicker than in the passages. So the correct answer to this question is actually B. It's equal to 2000 newtons. Let's talk about why. If the elevator is moving at a constant velocity, then there's no net acceleration and no net force. Therefore, the tension in the cable must equal the gravitational force on the elevator, which is given to you in the stem of the question of 2000 newtons. Cool. Done with physics. Yay. We all of us hate physics. Okay. Let's talk about chemistry. 5 questions, then we're done. And then we can talk about whatever, or everybody can leave and probably eat dinner. All right. Which of the following alcohols would have the lowest boiling point? So you have butanol, 2-methylbutanol, propanol, and ethanol. Give you guys about 45 seconds, and we'll talk about it. All right, 10 seconds. Let's get everybody participating. All right, so let's talk about this question. So D is the correct answer. So congrats to the people who chose D. Good job. So lowest boiling point. You're going to want the compound that in general is going to have the smallest, and you're going to want to have the least amount of polar substituents on that molecule. So ethanol, you only have 2 carbons and an OH. The rest of them So propanol, you have 3 carbons in OH, so that's automatic, C's out. Then B, you have 5 carbons in OH, even more carbons, that's out. And then butanol, 4 carbons in OH, you have more carbons than 2, so it's out. Each of them has an OH group, so that's not the difference maker. In this case, it's the number of carbons. Lowest number of carbons wins for lowest boiling point. Okay, number 2. Which of the following alcohols would be most soluble in water? Give you about 45 seconds, and then answer the choice, and then answer it, put it in the chat. Let's talk about it. Alrighty, so let's talk about question number 2, which is following alcohols would be most soluble in water. So this question, what are you looking for? You're looking for the alcohol that is going to have the least amount of carbons, because as the amount of carbons goes up, the amount of hydrophobicity is going to go up. It's going to be more water fearing. So the shortest alcohol that you have is propanol. You have the least number of carbons and H's, CH groups. Number 3, what type of alcohol is 2-methyl 2-pentanol? I'm going to draw it for you guys, and then we can, and while I'm drawing it, think about the question. All right, good. So let's talk about this one. So this one, you sort of needed to draw it out. So the answer to this one is a tertiary alcohol. And the reason why is the carbon attached to the hydroxyl OH group. It has 3 carbons attached to it. So it has carbon 1 attached to it, carbon 3, and it has this other carbon out here, this CH group. So it's a tertiary alcohol. You can eliminate primary and secondary because you have at least lesser number of carbons. Quaternary alcohols don't exist. It's not even a thing. All right. Which of the following reactions will undergo an SN1 reaction? We're almost there. Last 2 questions. So I'll give you guys a test taking strategy for this one to help you figure it out. So an SN1 reaction, what's the major determinant of what's going to make something SN1 versus an SN2? SN1, you're gonna want to have cation stability. So which group is going to have the most stable cation once you have the leaving group? And yes, the leaving group too. That's another determinant. Instead of leaving group. And the most important factor is going to be your cation stability once that leaving group leaves. So which one forms the most stable cation? So go and put your answers in the chat. All right, guys, let's talk about this one. So, like I said, the leaving group is a partial determinant in SM1 versus SM2. You pretty much have equivalent leaving groups here. So it's not really, that's not going to be the primary determining factor. It's going to be which one forms a stable cation once that leaving group leaves. Okay, so in the first compound that I drew, that's 1-bromopropane. You're going to have a primary cation. You only have one carbon. That's super unstable. That's not going to work. So B's out. Let's talk about 2-bromo-4-methyl pentane. On this one, you'll get a secondary cation. Better, but not great. On the 1-iodo-3-methyl pentane, again, you'll have a primary one. Ew. No good. No bueno. So B and D are out. Now for the tert-butyl bromide. Oh, let's see. We have a tertiary carbocation. That's going to be really good. It's going to be the most stable. So that's a general rule. Your tertiary carbocations are going to be the most stable. If you have a compound that can form a tertiary carbocation, it will almost always prefer SM1 over SM2. So the answer to this question is A, tert-butyl bromide. Makes sense. All right, very last question of the night, then we're done. And then you can either leave or you can ask me further questions and leave me feedback if you think I did a good job. Which of the following will undergo an SN2 reaction? So I'm going to start drawing these out. And then once you figured it out, put your answer in the chat. All right, guys, so let's talk about this one. So what's gonna make something want to undergo an SN2 reaction? Okay, you're gonna want a good nucleophile, number one. So let's go over what's a good and weak nucleophile, and that can actually get us halfway there. Water is a pretty weak nucleophile in general. There's probably a list of compounds somewhere on the internet that you can go and memorize, like what makes good versus bad leaving groups, but water in general is going to be a weaker nucleophile. Hydrogen chloride is a horrible nucleophile. It's just straight up bad. Nobody uses this as a nucleophile when you're doing organic chemistry. So C and D are out. Now let's go to our other determining factor. Other than a good nucleophile, you want something with the least amount of steric hindrance possible. right? Because in an S&T reaction, something's coming up behind and then kicking something off. So something that has a lot of bulkiness, like let's say this first compound right here, something that has a lot of bulkiness isn't going to be great because it's going to run into some things as it's on its way to attack the leaving group. So in this one, you have like a primary bromide, basically. You have a bromine that's like only attached to one carbon. There's only three other carbons here in this chain. It's a straight chain. There's not a lot of branching going on. So the potassium hydroxide, the OH, is just going to be able to sneak up right in behind and then kick off that bromide in an S&T reaction. So there we have it. That is all my very way too long MCAT prep session for today. So thank you guys for sticking around. I hope that was helpful for everybody and that my explanations made sense. If not, let me know and I can always try and do better for next time. We're going to be doing one in July. We're going to be covering biochem in July. And I'll better approximate time. I'll either make it shorter, or if you guys like the longer format, we can stick with more time and make sure we get through a lot. So does anybody have any lasting questions, feedback, concerns?
I have a question.
Yeah.
I just wanted to know, like, to physics, which would be, I guess, the high yield topics in which I should focus on?
Yeah, so that's a good question. And to be honest, in my experience and talking with friends and in my and on my own test, Chem Phys is one of the sections in which you can get a lot of physics content, a lot of chemistry content. And then moreover, the content that they test can be widely variable. So short answer, pretty much everything is high yield. In general, I would say that Physics 2 content, like electricity and magnetism, circuits, and lenses are going to be probably a little bit higher yield than your basic kinematics and things that you go over more in Physics 1. But things like torque and forces and energy and work, those are all going to be formulas to know and concepts to be aware of on your test.
Thank you.
Any other questions, like study advice, resources? I'm an open book, so I'll tell you my opinion about anything or any worries that you.
How long did you spend on content review? Because I feel like I spent a lot of my time on that. Now I need to practice a little more.
Yeah, sure. So I think content review, in my opinion, the optimum amount of time for content review is somewhere between 3 and 6. Like I probably about like, I'm trying to think how long I did content review for. Probably about two months, because I would say in general, 3 to 6 months of MCAT prep is what you should be aiming for. I myself took about 4, so about half of that was content review and getting through all the major content areas, at least on an initial walkthrough of it, and then focusing down based on practice questions, like what I was doing well and what I wasn't. So I'd say about half of your time should be content review. Yeah, of course. Any questions on general strategy or how to approach a passage? I know some of the passages were a little dense.
Hi, yeah, can you go over like any strategies on how to work on like timing and also going through like passages? I know you briefly talked about like how you just like read through and also looking at the questions. Like, did you look at the questions first and then look at the passage, or do you recommend just reading the passage and then moving on to the questions? Like, what's the best way to kind of go about it?
Yeah, sure. So to give some context, so on the MCAT, you're gonna have about 9 to 9.5 minutes for a passage. So some of the passages are long, and then you have about 4 or 5 questions. Then let's say you take a minute per question, and that's being really generous. So that's like 5 minutes answering questions and then 5 minutes to comprehend a pretty dense passage. So what I would recommend is going through the passage at least once and getting a big picture overview of what it's talking about. And do an initial skim, know where your tables are, know where any figures are, then read the questions. Because in one of the chemistry passages that we did, literally over half of the questions you didn't even need the passage for. Knock those out, get those done, and then go into the finer details of the passage based on what the question is asking you, is how I approached it. Yeah. I'll talk a little bit about MCAT math because I think that's something that really stressed me out on my exam. When you can round, when you can make things simpler on yourself, ask yourself, do I even need to calculate this? Or is this something that I can, using a little bit more conceptual, like, do these numbers seem way off or not so much? And then go from there. You do probably need to memorize some formulas. And I think there's some really good resources out there for high yield physics equations that you need to know. There's not a lot that you need to know for chemistry other than like radionucleotide decay. And I would know those formulas like forwards and backwards. So then if in a passage you need to recall it, you can, because usually they won't give you, especially in the discrete questions, they're not going to give you any formulas. All right, guys. It's 7 o'clock. Thank you for 7 p.m. CST or 8 EST for our people on the East Coast. That was really long. Let me know in the Slack, like message whether you enjoyed the session. And if you like the longer format or if you want it to stick closer to 45 minutes, so I can know what to do for next time. I'm going to be going over biochem, which is going to be higher yield for medicine in general, because the first class that you take in medical school is biochemistry, pretty much everywhere. So that's what we're going to be going over next time. So everybody have a good day. I hope this was educational and useful, and I kept it a little bit fun, and you learned something about medicine too. And I'll see you guys next time in July. Okay. Have a nice night.